This is Miss Steele's Precalculus class. We are going to be starting Chapter 7, starting with 7.1, Day 1, talking about trigonometric identities. Trigonometric identities. We are not going to be discussing anything new for this first part. Reciprocal identities are things that we have learned about and talked about many times in the last couple chapters. We know that we can rewrite sine of x as 1 over cosecant of x. We know we can rewrite cosine of x as 1 over secant of x. We can rewrite tangent of x as 1 over cotangent of x, and we can rewrite tangent of x as sine x over cosine of x. This is nothing new, but we will be using these throughout the rest of Chapter 7. Pythagorean identities is also something that we have learned. Pythagorean identities are just derived from the Pythagorean theorem. So if we ever forget one of the Pythagorean identities, we can always recreate it. We know that sine squared of x is the same thing as y squared, and we know cosine squared is the same thing as x squared. If we thinking of the Pythagorean theorem, that tells us that if we have a right triangle, a squared plus b squared equals c squared. In the unit circle, our radius is 1, so 1 squared. One of our side lengths will be y, and the other leg of our triangle will be our x, and the radius will always be 1. And this is why y squared plus x squared equals 1 squared. That's why this works for the unit circle. So that's how we end up with sine squared of x plus cosine squared of x equals 1. We can derive the other two Pythagorean identities. The first one is just by dividing each term by sine squared of x, and the second one we get by dividing by cosine squared of x. The next thing we will take a look at are even odd identities. This is also nothing new. We know that if we have sine of negative x, that makes negative sine of x. Same thing goes for cosecant. If we have cosine of negative x, that makes positive cosine of x. And same thing goes for secant. We end up with a positive secant of x. And then for tangent, if we take tangent of negative x, we end up with negative tangent of x. So if we ever have a trig identity or trig function with a negative x, the only one that becomes positive are cosine and secant. Confunction identities, or cofunction identities, is the one piece of new information that we'll be learning and using on a daily basis throughout Chapter 7. If we have sine of x, that is equal to cosine of pi over 2 minus x. The same thing, and then if we have cosine of x, that's equal to sine of pi over 2 minus x. So these two, we can switch back and forth. The same thing goes for tangent of x and cotangent of x, and also for cosecant of x and secant of x. It's also important to understand that you can replace that pi over 2 with 90 degrees. So this works for radians, and degrees. It's an important point to highlight. So throughout Chapter 7 and throughout 7.1, we will be using all of these identities that we have just went over to rewrite trig functions in terms of different trig functions, so we can verify that two expressions are equivalent to each other. So examples 1 and 2 ask us to use a cofunction identity to answer the following questions. Number 1 is sine of pi over 6. Obviously, we know what sine of pi over 6 is because it is a number it's a value on the unit circle that we know. But to just see if we can use a cofunction identity to make sure these two values equal each other, let's try it out. We know that sine of x can be rewritten as cosine of pi over 2 minus x. In this case, x is pi over 6. So just replacing pi over 6 with x, we know this is equal to cosine of pi over 2 minus pi over 6. In order to subtract these two terms, we need a common denominator because they're both fractions. So a common denominator of 6, this becomes cosine of 3 pi over 6 minus pi over 6. Then we know 3 pi over 6 minus pi over 6 is just 2 pi over 6. And simplifying this further, we know this is equal to cosine of pi over 3. Cosine of pi over 3, thinking of our unit circle, we know is equal to 1/2, which we can check ourselves at the beginning. Sine of pi over 6 is also equal to 1/2, so we know we did our math correctly. Number 2 asks us to find tangent of 47 degrees. We know that tangent of 47 degrees, we know tangent of x is equal to cotangent of pi over 2 minus x. And since pi over 2 and 90 degrees can be used interchangeably, this is also equal to cotangent of 90 degrees minus x. Since x is given to us in degrees, we want to use the 90 degrees minus x. So tangent of 47 degrees is equal to cotangent of 90 degrees minus 47 degrees. Cotangent of 90 minus 47 is equal to cotangent of 43 degrees. And using our calculator, making sure we are in degree mode, this is equal to 1.07. So 7.1 really deals with simplifying trigonometric expressions. So some techniques we can use. First is substitute an identity. The second step is to change all terms to sine and cosine, sine and or cosine, so sometimes you won't be able to change it into both. Third step is to multiply by a form of 1. An example of this would be multiplying by tangent of x divided by tangent of x. Another example would be sine of x divided by sine of x. And something else we can do is get a common denominator. Something else we could do is try factoring. And then another thing we could try is multiplying by a conjugate. This section in pre-calc is something that really ties all of mathematics together. This is one of the first times that you will have to use all of the knowledge from past courses, like geometry, algebra, everything that you have learned in middle school, from elementary school all the way up to where you're at now. But this box is just an important box to highlight. It's something that we'll be using all the time, and when you start trying problems, it's very unlikely that you will get an answer right away using the first thing you try. You may try to substitute an identity and it may not work. You may be working on these problems for a couple minutes and you start getting frustrated. It's really important to understand that these take time. So if one thing doesn't work, take a little break and try something else. The same thing will not always work each time. Example 1 asks us to simplify the expression. So let's for number 1 is tangent of x times cosecant of x all divided by secant of x. So let's try changing each term to sine and cosine. So tangent of x can be rewritten as sine of x over cosine of x. Cosecant of x can be rewritten as 1 over sine of x. That's all divided by secant of x, which secant of x can be rewritten as 1 over cosine of x. So now it's important to understand that the sine of x's in the numerator will cancel. Then we are left with 1 over cosine of x divided by 1 over cosine of x. Notice that 1 over cosine of x and 1 over cosine of x are the same thing. So this is just like dividing, it's dividing two things it's dividing by the same expression. So those cancel out and we're just left with 1. Completely simplified out, we get an answer of 1. Number 2 is cosine of x all divided by secant of x minus tangent of x. So let's again try changing each term to sine and cosine. So obviously cosine of x we're going to leave alone. So the numerator stays cosine of x. Secant of x can be rewritten as 1 over cosine of x. And tangent of x can be rewritten as sine of x divided by cosine of x. Notice that we now have a common denominator in our denominator. So we can rewrite this again, combining 1 over cosine of x minus sine over cosine of x. This becomes 1 minus sine of x divided by cosine of x. And now if we multiply by cosine of x in the numerator and denominator, cosine of x by cosine of x, this is the same thing as multiplying by 1. So we are using another one of our strategies. Now our cosine in the denominator gets canceled out, and in the numerator we are left with cosine squared of x, and in the denominator we are left with 1 minus sine of x. This is so now cosine squared of x can be, we can use one of our trig identities we know. This is the Pythagorean identity. We can rewrite cosine squared of x as 1 minus sine squared of x. And our denominator will remain 1 minus sine of x. Now we can use our factoring skills from algebra. 1 minus sine squared of x can be factored into 1 plus sine of x and 1 minus sine of x. And our denominator will remain the same, so 1 minus sine of x. Notice that we have a 1 minus sine of x in the numerator and denominator, so those two terms will reduce and they will cancel out, and we are just left with 1 plus sine of x. This is as simple as we can go, so we can box up our answer. Example 3 asks us to simplify sine of x times cotangent of x. And again, we will just try changing each term to sine and cosine. So sine of x will remain the same. And then cotangent of x can be rewritten as cosine of x over sine of x. Notice we have a sine of x in the numerator and denominator, so those sine of x will cancel, and we are just left with cosine of x. That is your final answer. Number 4 asks us to simplify tangent of x divided by cotangent of x. This time we will use a reciprocal identity. So we know that cotangent of x can be rewritten as 1 over tangent of x. This is the same thing as tangent of x times tangent of x over 1. We're just taking, instead of dividing by a fraction, we can multiply by the reciprocal. And then we are left with tangent squared of x. And that is as simple as we can get. And lastly, for number 5, we have cosecant of x divided by 1 plus cotangent squared of x. We will use a Pythagorean identity. So we know 1 plus cotangent squared of x can be rewritten as cosecant squared of x. So since we have cosecant squared of x in the denominator, we have cosecant of x times cosecant of x, and 2 of our cosecants of x's will cancel out, and we are left with 1 over cosecant of x, which we can rewrite as sine of x. So sine of x would be the simplest form we can get.